Okay, thanks everybody. And just a reminder, if you're interested in getting copies of any of these presentations, please have your badge scanned at the entrance to the IP showcase here. And we will be posting videos from these discussions and sessions and whatnot at vsf.tv and on the VSF YouTube channel. And we'll also be distributing links to those as well. So now it's my pleasure to introduce Robert Erickson with Grass Valley, and his job here is to talk about another real application, things that people are actually using ST 2110 for. So case studies, we love them.
Yep.
Take it away, Rob.
Thank you, Wes. Appreciate it. Hello, everybody. How you guys doing? So I am here to talk about doing great things. Nothing that I did, thankfully. It's other people that do the great things. But one of the biggest things I think in the industry we're doing is so often we are taking the exact same workflows we did in SDI, and we're just replicating them in IP. The industry has spent, between Cisco and Arista and Grass Valley and all the other big companies, the industry has literally spent billions of dollars to create a new technology. Yet largely we're doing things the same way we always did. Customers will come to us and say, hey, Robert, we want to build an IP installation. Great, why? Because it's IP. That's probably what we're supposed to do. Well, how do you want to improve? How do you want to do things better? What new things do you want to try? Oh, we just want to do what we've been doing. We just want to be doing it in IP. In all fairness, there's some business cases for that, but that's not what us as an industry need to be doing. We need to be finding new ways to be using new technology to create new workflows and new solutions. And that's something I want to focus on this. And this is it's a production done by SVT in Sweden. And it was the Alpine World Ski Championship. First off, by the way, I wasn't at that event. I live in Southern California. I live in Los Angeles. But you'll see some of these pictures that of our cameras completely frozen over, and some of the gear completely frozen over, and I really commend anybody who did that work in that environment. That is some really intense stuff. But this was remote production. And this was all about how can we produce the content in RE and then bring it all the way back to Stockholm, which is 600 kilometers away. But they didn't want to roll a truck. They wanted to do a new way of doing this. They didn't want to just do it the old traditional way they've always done it. By the way, this picture right here, when I was putting together the presentation, made me be very happy to live in Los Angeles. It's not that I don't mind that from time to time, but I don't know if I want to be standing in it for 2 weeks. But SVT had a really complex and a very challenging set of requirements. They had to do 80 cameras remotely, all controlled back in Stockholm. 80. This isn't some of these remote productions are 12 or 15 or 16 cameras that we do. This is an 80 camera shoot. Fairly obviously, but it does actually have to be dictated. We wanted no difference in the viewer experience. If the viewer cares that we did this remotely, we probably did something wrong. They want the highest content they can possibly have at the home. You can't compromise that just because you're doing it remote. But why do it remote? There is a lot of efficiencies that can be gained. Fewer again, kind of makes sense. If we have to add 18 seconds of compression to do this, for some people, that's a no-go. And synchronization is always a given. We have to have all the cameras need to be frame accurate when they come back to the facility. They brought the requirement of no OB vans at the remote site. That's the big challenge. Because OB vans, that's your tech core. That's your routers, that's your multiviewers, that's your processing core, that's your up-down cross converters. That's everything you need to normalize the facility. They did not want that at the remote site. And this one is really interesting when you deploy new technology. It needs to be a sustainable workflow. Anybody can do an incredible production once with a giant pile of cash. But it's not reproducible, it's not sustainable. So how can we develop the technology? How can we develop the workflows that are reproducible and that are monetarily sane? Those are the requirements that they brought. So this was the setup. Again, we had 80 cameras at the remote site, about 150 people. And this is the important part. And I'll talk about this a little more in detail, but the director and the TD wanted to be on site. Doesn't seem like that big of a deal, except that the switcher was actually in Stockholm. The multiviewer was in Stockholm. The camera CCUs were in Stockholm. Everything, the routing, the replay, everything was in Stockholm. So it wasn't that we just simply took our cameras and remoted them back into Stockholm, but we also had to have return feeds from Stockholm with the multiviewer mosaics and preview program out of the switcher and stuff like that, sent back to the remote production. So how do we synchronize that? How do we do that workflow? This is unique. We're seeing most remote productions are sticking the director near all the gear and the TD near all the gear. Honestly, I love the originality of it. It made sense for them, and they did it, and it worked. That's the thing to remember. But here's the part. So by the way, in the US, it's not that easy to get two 100 gigabit links that go all the way across the country. Like if you're Comcast or something and you don't mind spending a few $100,000, sure. But most people in the US and large parts of the world don't have the availability of getting 200 gig pipes for an event like this. Apparently in Sweden, you guys get awesome bandwidth, so I'm quite jealous of everything you do there. The reason I wanted to include this picture is when people think of IP, they think of the gear you see here at this facility. How much of this gear here do you think would be good sitting in the snow on top of a mountain in Sweden? That's one of the unique challenges. Out of this camera is coming IP. There is no converter. We're not converting from baseband to IP at the back of the camera. The camera itself, at the camera, generates the IP stream. And it's hardened. It can take the wind, it can take the cold, it can take the ice, it can take the abuse. That's something that we have to do in IP. Now we have to harden the connectors, and you just can't put an ST fiber on the back of the camera and expect it to work. So there's some stuff you have to do to harden the connections and things along those lines. But IP products designed correctly work the same way as you'd expect out of SDI or SMPTE fiber or Triax or things like that, and that's one of the requirements. You just can't treat it, you can't change your workflow, you can't change how you use a camera just because it's IP. Big requirement. So this is some of the pictures of the multiviewers. This is still during the construction stage inside. And this is the production area in Stockholm. So you notice they're running audio in there. They got the multiviewers. You have your producers. You have your ADs. You have your APs and all these kind of people that are all in Stockholm. And then, of course, the TD and the directors are in at the remote site. So on the technical highlights, everything was centralized. Everything went back to a common room in Stockholm. So all the remote gear, everything, all the processing engines behind them. Again, the camera CCUs were not at the remote site. The camera CCUs were in Stockholm. We're doing IP from the output of the camera straight to the CCUs. We'll dive into that a little bit more. And it's an end-to-end IP remote production infrastructure, leveraging SMPTE 2110, SMPTE 2022.6, AES 67, and things like that, which we'll dive into more. And that comes back to the open standards architecture. Anybody can make a proprietary solution work, if you're that one vendor. But how's that going to work? And to repeat what the lady from the BBC said, the open architectures is what the customers want. They want the ability to pick the best of breed. They want the ability to pick what fits their solution the best. So you have to make your infrastructure work with open standards. So this is the camera setup and also some of the processing gear on at the local site. So we had 50 LDX86N cameras. 6 of them were at 6-speed super slow-mo. 7 of them were at 3-speed super slow-mo. Mind you, this is all IP. This is all over 2022.6 and SMPTE 2110. We also had another 37 single-speed cameras, all feeding Arista switches. That was doing our aggregation and our muxing into the two 100 gig pipes. Then you'll also notice here we have a breakout for the return for the comms, for the switcher control panel, and then also for the multi-viewers and things like that. So that's the return feed that we had coming back from Stockholm. So in Stockholm, this is one thing I thought was very well designed. The customer had an existing SDI infrastructure. The customer had an existing multi-viewer solution. So this is an end-to-end IP solution where the customer didn't have to go in and blow out their entire facility and make it all IP. We had the ability to take IP and leverage that into their existing SDI infrastructure. We had the ability of taking IP and make that work with their multi-viewers and their routers and everything else. And again, that's what I consider a very well-designed solution. You don't necessarily have to go in and blow your entire facility out just to go IP. You can put in IP where it makes sense, and the assets you have on the books that are still valued to you, you can still keep using them. We also did a Net Insight, or the customer chose a Net Insight box for some compressed feeds, some proxy video and compressed feeds to go back to the remote site. So this is a combination of a uncompressed 2110 to 2022.6 system and a compressed system bringing some of the return feeds back. One other thing to point out is you see the 50 UXF XCUs. Again, that's the base station at the remote, or at the Stockholm site. Native IP out of the camera, straight back over the Arista switches and the 100 gig links to be broken out at the XCUs. When we design facilities, this is something you have to think about, and this is just a good question for everybody to have. If properly architected, does it really matter what the transport is for your cameras? Does it have to be 200 gig links? Maybe if you want to go over a WAN that has limited space, maybe you can compress it. Or maybe you can mux them together. Or maybe there's a lot of different options that we have here. So when you start designing your facility, so one thing that we always think about is you don't design it for one area. You don't design it for one solution. You don't design it for this one option, this one workflow. The ability to say, you know what, this solution could work over a WAN, this solution could work over a LAN. We need to blend those lines because that's the reality of what it is. Bandwidth is getting cheaper. Connectivity is ubiquitous, especially high speed in most of the world. We've got to start blending the difference between a workflow, or a WAN workflow and a LAN workflow. So this is the exact camera configuration that we had. Each camera and an XCU is direct connected to an IP network. So the way this works, because it works over standard IP protocols, is the base station is on a network switch. The camera is on a network switch. When you plug them both in, using standard routing, they just find each other and it works. It's that simple. And this isn't just applicable to remote production. There's places in the world that we have where it's campuses and where it's TV studios where they're always moving cameras around. And I'm sure everybody here has had a patch of Triax or had a patch of SMPTE Fiber a time or 1,000 as they move cameras around. Well, what if you never had a patch? What if those all were IP? You just plug the cameras in and you're done. That's the workflow we're going for. So robust fixed IP network infrastructure. You'll notice that we had redundant 100 gig links, we had redundant switches and so forth. There's no single point of failure. That would be an absolute travesty to have 80 cameras into one single fiber. That fiber goes down or that switch goes down and you lose the entire production. That's kind of how to not do those things again. Use of COT switches. There are proprietary IP switches out there. Why use them? Why not use a Arista or a Cisco? In this case, it's an Arista switch that just leverages the technology of a COTS platform, using open standards, and you go on your way. Easy to scale up. We're treating media as a function of bandwidth, and that's the important part about IP. You know, when we're doing cameras and when we're doing video over coax or SMPTE Fiber, your media is a function of the cable you're plugged into. It's almost impossible to do new workflows that way. But if you treat media as a function of bandwidth, if you remove the physical interface from the equation, now you can just switch it over COT switches and things become a lot more flexible. And also there's the lower investment because you don't necessarily have to run SMPTE Fiber all over creation. That stuff adds up, especially when you're doing 80 cameras in a remote location. So how does direct IP work? How does the connection work between the camera and the base station? Well, traditionally you have your single fiber. And inside that fiber, you have this. So what we've done is we've created all of these individual trunks over standard IP connections. The main video is 2022-6. The audio is AES 67. And then we have some proprietary stuff for us to control the cameras, just how it is now. Because ISO 7 wasn't really around at the time this happened. And so this is everything you'd normally see in a standard SMPTE Fiber over an IP trunk. The cameras work exactly the same. The operators don't know that it's not SMPTE Fiber. They don't know that it's IP. They don't know that it's Triax. Everything that is traditionally in the SMPTE Fiber is being transmitted over IP. Simple as that. Again, that makes deploying the workflows very, very easy because people don't know the difference between the traditional way and the new way we're doing it. And also, the bandwidth requirements also do depend on the operational mode. And this is one part about how do you use compression effectively. I'm not necessarily a huge fan of compression for all workflows. I'm also not a fan of doing uncompressed for all workflows. But one thing I can say is when you go to UHD production, that is a massive payload hit. 12 gigabits per second chews up exactly that. It's a massive amount of bandwidth. So there is areas where going to a very light compression, such as TICO, makes a lot of sense, especially when the compression only adds 20 lines of delay. It just makes a lot of sense. So this is the bandwidth graph on the different kind of cameras and the different formats and stuff that we're using in terms of what the bandwidth was in real life. One thing I do like to point out is that 2110 is a significantly more efficient way of transmitting video over IP than 2022-6. 2022-6 is just SDI encapsulated in IP. So even if you're running 720p and your data rate is significantly less than 1.5 gig, we're still going to pack that with null data to get that 1.5 gig we expect. So you notice on the graph that on some of these signals, especially 1080p's and stuff, we use significantly less bandwidth on 2110 because we're just transporting the active pixels instead of a full raster like we do in 2022-6. So again, these are considerations you can bring into when you're doing a bandwidth calculation. When you do 2, 3, or 4 cameras, this kind of bandwidth deviation doesn't matter that much. But when you do 80 cameras and you're packing those full of null data, that ends up having a very big impact on your overall bandwidth. Something to consider. So what this leaves us is 3 options for doing IP over the remote production. And by the way, I'm using our cameras just as an example, but this works for any sort of remote production. You can go your traditional 10 gig IP communication or your traditional SDI connection. Once you go to direct IP or once you go to IP workflows, you notice we have the addition of a 10 gig LAN or 20 gig, 5 gig LAN or 50 gig or whatever bandwidth requirements require, and you're done. You have it, you're uncompressed. But if you use a vendor, if your solution uses SMPTE 2110 or 2022-6, why not compress it if you want to? Why wouldn't you just route that 2110 signal to a compression codec or a 2022-6 signal to a compression codec and be able to pick up the compression benefits if you want? That's the benefits of using the 2110 protocol or the 2022-6 protocol in this case, is you can do exactly that. So at this site, we put the numbers in there because we did work with them a little bit, and we did have a 1 gig WAN that we did use compression on. And that's the ability to blend your uncompressed and compressed workflows as you go through the environment. The director did want to be on site, as we mentioned previously. So the output of the switcher fed in Nimbra, went back out to that, and we broke out the control panel, and we broke that out to the multi-viewer at the remote site. That was a unique requirement they had. We were easily able to support that. Again, open standards, open protocols, so we have multiple vendors working together to deliver a solution. I'm not saying this is a Grass Valley solution, it wasn't. This was a combination of vendors working together to deliver the solution the customer wanted. And that is the case study on that. That's the overall on it. So I'm sure Wes is going to grab a mic while he's doing that. Do you guys have any questions or comments or thoughts or anything on what we're able to see or do?
So do we have any questions? Yep, hold on.
Just on the venue side of things, where were you injecting power for the cameras themselves? Near the cameras?
Near the
or
camera.
Did you had no sort of like shed farm or type of thing?
That's exactly what it was. So we're using sheds to inject power in the cameras.
And then just taking that single mode out and
Yeah.
it goes into the...
And so that varied on the location because we're using a shed to inject power. Some of the cameras had like an 8-foot tail coming off the bottom of them. Some of them had a few 100-foot tail coming off of them. It just depends on where the need of the power to be injected.
Okay, cool.
So I had a question. You said that one of the things is that you didn't want the viewers to see any difference. What about the people that were, shading the cameras and doing the hands-on? Were they able to tell that they were remote from the cameras or not?
Very little. Because we stayed uncompressed, the network switches themselves actually only add a few lines of delay. It's a very, very small amount. So our biggest complication was the time of flight of the light down the fiber. But it was, I hate to say it's only, but it's actually only a few hundred kilometers. So that was actually ended up being about a frame of delay. Since most humans' perception is 2 to 3 frames of delay, most people can't see anything less than 2. Almost everybody can see 3 frames of delay. We were well within that window of what humans could see. The only area that there was a little delay is when the cameras went all the way back to Stockholm. They shaded them there. The shaders didn't see any delay. But then we put it back into the multi-viewers. The multi-viewers came back out IP into the Nimbras, and then they hit a J2K codec and went back out to the remote site.
Okay.
At that point, we hit about 4 frames. And the person paying a lot of attention, if they had a raw camera feed and the return camera feed, they can see a little bit of delay. But that's the only place where that was applicable.
Okay. Any other questions? So do you think they're going to keep doing it like this?
Absolutely.
Okay.
Yeah, they made the investment on the gear, and so there's no reason they can't use that same investment at different sites. As long as they get the connection and the IP, they got it.
Okay, great. Anybody else? Okay,
Thank you
Robert.
very much.
Thank you very
I
much.
appreciate it.
Okay, we're gonna kick off our next presentation at 2:00 on schedule, and so we'll be back with you in about 10 minutes. Thank you.